Question 4. So magnesium has got an atomic number of 12. Which line in the table shows the correct number of protons, neutrons and electrons in a positively charged magnesium ion? So they're not asking about an atom, they're asking us about an ion. So we've been told that magnesium has got an atomic number of 12, and so that tells us the number of protons that are present in magnesium. So if there were 13, we wouldn't have magnesium anymore, we would have aluminium. If there were 11, we'd have sodium, and so 12 is always fixed for magnesium. So we can look at our table and we can automatically rule out A and B because we have to have 12 protons in both. Okay, now they're telling us that we want to have a positively charged ion. So that means that ordinarily in an atom, we would have 12 protons and we would also have 12 electrons. But we are looking for a positively charged ion, which means that we have lost some electrons. So we no longer have 12, so we have less than 12 electrons. And so if we look at our possible answers here, we've got C, which has got 12 protons and 12 electrons. That would be an atom because it's neutral. 12 plus, 12 minus. So it's not that one, which means that we're left with answer D with 12 plus, 10 minus. So that gives us a positive, two extra positives. And that's correct because magnesium forms magnesium 2 positive. So the answer is D. Calcium oxide is an ionic solid. Figure 5 shows the arrangements of electrons in a calcium atom and in an oxygen atom. So here's calcium and here's oxygen. Complete figure 6 to show the electronic configuration and charges of the calcium ion and the oxide ion. Use dots to show the electrons originally in the calcium atom and crosses to show the electrons originally in the oxygen atom. So let's have a look at calcium here. Okay, now calcium, if we go to the periodic table, okay, in our in the back of our answer booklet, and we find calcium, it is in group 2. Okay, so that means there are always 2 electrons in the outside shell. And when any atom becomes an ion from group 2, they always lose those 2 electrons to become a 2 plus ion. Similarly, group 1, they've got 1 in the outside shell, they would lose 1 to become a 1 plus ion. So calcium, we know, is going to lose 2 electrons. So we know the charge is going to be 2 plus. It's going to lose 2 electrons. So what we have to do is we look at our shell and we can see here that we want to lose 2 anyway because there's only 2 on the outside and it wants to go down to 8 with a full shell. So let's add in 8 for our full shell. 1, 2, 3, 4, 5, 6, 7, 8. And so if we look at the total number it has, it's got 2 plus 8, that's 10, plus another 8, that's 18. Ordinarily, there would be 2 extra to make 20. And if we look back at our periodic table, that's correct. Now let's look at oxygen. Okay, oxygen is going to have in its outside shell, it's got 6. 1, 2, 3, 4, 5, 6 in the outside shell. It wants to have 8 in the outside shell, so it's going to receive 2 electrons. So now it's got 2 more minuses than pluses, so it becomes 2 minus. And let's draw in our extra electrons. So those are the ones that it's got already, but I'm going to draw my next 2 as dots to show that they have been given to the oxygen by the calcium. Okay, part C. In an experiment to determine the empirical formula of magnesium oxide, the mass of oxygen combined with a known mass of magnesium must be found. Describe, okay, so that's going to be writing down a list of instructions, an experiment to determine the mass of oxygen that combines with a known mass of magnesium in a crucible and lid of known mass. So this is one of the experiments that you should have done. So the first thing, if you can remember, you have a little crucible that looks like this. You put your coil of magnesium inside it, and then you put a lid over the top and you heat the magnesium strongly. And what happens is, as you heat the magnesium strongly, it reacts with oxygen inside the air, okay, trapped in the crucible, and this goes from a shiny strip to a white powder of magnesium oxide. So instructions or describing the experiment, we would start with heat the magnesium in the crucible, and every now and again you would lift the lid very carefully just to allow a little bit more air in. We don't want to use up all the oxygen in there and then have no more coming in to react with the magnesium. So lift the lid occasionally. And then at the end, they've told us that we've got a known mass of magnesium in a crucible and lid of known mass. So what we would do at the end is we would weigh the crucible, lid and magnesium oxide. And then we would take away the mass of the crucible, lid and magnesium, and that would leave us with the mass of the oxygen would be left over. Okay, question D. So a sample of aluminium chloride was analysed. It was found that 0.270 grams of aluminium was combined with 1.065 grams of chlorine in this chloride. Calculate the empirical formula of aluminium chloride. So, and you must show your workings. Okay, so that means if I write my answer, just the answer, I won't get any marks because I have to show my working. So empirical formula is a bit like simplifying in maths. It's kind of the lowest form that you could get to. So let's write down, first of all, we're going to start by writing down our two elements, okay, that we're using. So we've got aluminium and we've got chlorine. And we know that we are using, the mass that we are using is 0.270 grams of aluminium, and we're using 1.065 grams of chlorine. Okay, and then to find the number of moles, and that's basically what we're doing here, we need to then divide it by the atomic mass. So it's always a good idea to write it out in this format. So you've got mass first, and then you've got atomic mass, and then you divide mass divided by atomic mass to give you 0.01 0.03. Now this is just a ratio, okay, so to round it up into whole numbers to make it a bit easier, I can just divide it by the smallest one. I mean, it's easy to see for this one that it's a ratio of 1 to 3, but if it's difficult numbers and you can't work it out, divide it by the smallest. So if I divide it by 0.01, 0.01, this comes to 1, this comes to 3, so I know that I have a formula of Al1, I'm not going to write the 1 there, Cl3. That is my empirical formula.